Alright, both streams are running. We'll see how that goes. Wait, what the hell is with the window? Never mind, that page is weird. Can you check ourselves on the stream?
Okay.
We're gonna go back to the intro page, intro slide. Yeah, seems like we're working. Can you hear us talking?
Yeah, so I think for the intro page, we shouldn't have our voices in the background, right?
Yeah. Enable, microphone enable. Good to go.
All right, cool. We live, Lewis?
Yes, we are.
Awesome. Hey, folks. Welcome to this rendition. Lewis, did you have a title for this?
No, just demo.
Okay, so let's actually change the title. So what we're going to be talking about today is how to use WASM in Chrome extensions. I think this is a topic that people are really interested in. WASM is this new hot technology that isn't all just hype. I think there's a lot of really interesting technology behind it that we're going to be talking about today. So that's what we're going to be discussing. Maybe, let me see. I should get the creator dashboard up.
Mm-hmm.
Do you know how to change the title of a stream?
On Twitch?
Yeah.
I can. Yeah.
Okay. Oh, I'm not logged into Plasma HQ. Let's have this title for WASM so that folks curious about it can
All right. 1 second.
see us.
Trying to find stream information. Here we go. Got it.
Makes sense.
Okay, so I'm doing demo. Should we put it on title? In the title?
Yeah, I think the demo should be how to use WASM in Chrome extension.
Okay, how to use WASM in Chrome extension. Alright then. Publish. Alright. It should be updated now, I think.
Awesome. Cool. All right, well, before we jump into WASM, Lewis, we have some exciting product news.
Yes, sir.
What's going on? What's the deal with all these content script UIs? Why are they all over my page? What's the latest?
Yeah. So, actually, I realized I didn't have anything showing, but let's just have the chat. So, last week I was working on this feature that a lot of people have been talking about. Basically, a way to mounting a component onto multiple items on a page, right? So, yeah. So I mean, that's pretty much it. You know, that's pretty much how can a user easily supplying a list of HTML node and mounting the same component on all of them. Yeah. So that was the question. That was one of the problems that a lot of people were facing, and so the PR that we just merged is going to fix that problem.
Do you wanna do a demo of it?
Yeah.
Let's do it.
Let me switch over to screen sharing demo. Okay, more screen sharing. You can see it, right? On the stream.
See it now, yeah.
All right. Yeah, we also have. Yeah, we remove that. Okay. So, yeah, I really want to. I in the future I want to crop our image so it's like square, so we have more screen, we have more space for our screen. All right. Oh yeah, for to those who have not noticed, we are moved over to OBS. The streaming software we're using has some trouble. So anyway, oh, this is the sandbox page in demo. But this is my inline CSUI experimentation. So first, let's just try it out with nothing, right? So here's a page with nothing on it, like Gmail, right? Just Gmail. This is a test Gmail account with like just some email, right? And the idea is that I kind of want to mounting a component onto each and every of these kind of like email item, right? So I would enable the CSUI kind of experimentation and refresh the Chrome extension. The Gmail page, and voila, we have actually two type of overlay, two type of anchor here. The first one is actually inline anchor. This anchor here, this inline button, actually is inserted into the Chrome, into the Gmail element itself. And over here we have the overlay. The overlay is an element that's positioning absolutely on the page. It's just hovering on top of the element that you want it to be on top of. Yeah, and the code for this is very simple, very straightforward. For inline, let me make the text a bit bigger here. Can you see? Oh, should I make it bigger?
Yeah, no, that's perfectly fine.
Alright, so let's go to, so here's the inline button for the Gmail demo. That's all you need to do. All you need to do is exporting a get inline anchor list, which returning a node list of element, which is basically it should be the output of document.query selector all. And that's it. And then you exporting a React component, and that should do all the heavy lifting to render all the inline button for you on the page.
So what you're saying here, Louis, is that this get inline anchor list, you're telling it like, hey, I want you to put this React component that I'm exporting down below. I want you to put it like next to all of these different nodes that I'm returning in get inline anchor list.
Precisely, right? Yeah.
Cool.
And then
what does the overlay look like?
Yeah, overlay very similar. Get overlay anchor list. I just give it a list of all the overlay all the anchor that I want it to be. In here, actually, here's a cool thing here. We actually passed out the anchor. So you can actually access the element inside the anchor and get the inner text or getting whatever you want from it, like ID or whatnot, like even like the property of the element. And so in here,
is that also provided in the inline example?
No, I didn't do that. Yeah, it does though. For inline, yeah, you can actually also just use the anchor here and use it here, similar to the overlay anchor. Yeah, this is just an example. And yeah, the cool thing is, as you can see, you can hit the overlay button for no reply to. No reply to is whatever text I have behind this thing. And also the awesome thing is that, okay, the overlay anchor is actually optimized a lot, especially for React. For Svelte and Vue, the multiple overlay anchor is a bit not quite. I just spawned multiple instances on Vue and Svelte. But on React, I actually did a little bit of optimization on the React side, so that all of these overlay anchor are actually mounted on a single React component. Actually, all of them mounted on a single Plasma CSUI Shadow DOM component. That they're all under the same kind of overlaying kind of Shadow DOM. Yeah, so this basically just, yeah, also actually we introducing this Plasma CSUI element here. So that it's basically our Shadow DOM kind of a wrapper. Kind of cool, right? You have your own tag. Yeah.
That's awesome.
Yeah, but the idea is that it actually selectively monitor if these elements are kind of visible or not. So when you go to a different page, it's actually, because the item is not visible anymore, it doesn't show. Yeah.
That's awesome.
So sometime, right? Even so, one of the things I was testing, right, while I was working on this, was that when you go to this page, right, those elements will actually, you can still query those elements, which is why the for overlay anchor, the visibility test is important, because I can just do this. I can query for them right here, like, so that is the same. So this is still the email. So apparently on Gmail, all the elements for your email, right, these tabs are just like, I think they are kind of filter tab. So the element's still there. They just filter whether they are shown or not.
Oh wow.
Yeah. So it's not separate page at all. And so yeah. So that's why for each of these elements, when we creating the overlay anchor query, when we query for the overlay anchor, for inline we check if they are mounted or not. For overlay, we actually check if they're visible or not. Because on overlay, we actually mount the component on top of the entire page, right? We're not just inlining them. So that's a bit of a difference in how they implement. But it turned out pretty nice. I like it. I like how it turned out. Yeah.
That's awesome.
Yeah. Also, another fun stuff that I just discovered, thanks to one of the, community member, right? Apparently, you can do eval with sandbox page. And so what you can do is you can send messages from a pop-up page to be eval in a sandbox page, and then get the result from there. Which is pretty fascinating. So here's the example. So over here I have this sandbox page, right? That has add event listener. It's look for a message, and then inside it do an eval with the data inside, right? Event data is just a string, right? And then in my pops up, I do an iframe. So I render that inside a hidden iframe, right? So I render that sandbox inside hidden iframe, and then I did content window.post message. I post what I wanted to eval, and then over here I have a event listener listening to the message, and it get the output of the eval. It actually worked, which is quite interesting. Yeah. So this is kind of a way to do eval, I guess. We can abstract away all of this actually into something that we can use as well.
Yeah, that sounds good. I think this will get rejected on the Chrome Web Store, but it would be useful to have for like HMR or something like that.
Yeah, or the case where you don't care about the Chrome Web Store, then
yeah,
who
exactly.
cares? Like, I mean, who gives a shit about Chrome Web Store? Go to either store, man.
All right, so
No, actually,
cool. That sounds good.
That's a bit too cocky.
So now let's talk about kind of we talked about multi CSUI. So that's pretty awesome. But one of the things that we've been kind of experimenting with for the past couple of weeks and months, Lewis, is WASM. So for those who don't know, kind of what is WASM?
Yeah, actually, let's go to discussion view. By the way, are you looking at the stream?
Yeah.
Yeah. So I'm just swapping into the view, the two-person view, making it easier to talk.
Cool.
Yeah. So.
Okay, so what is WASM?
Yeah. So WASM WebAssembly, right? WebAssembly, whatever it is. What is S and M? I don't know.
I think it's
Oh,
WebAssembly.
yeah, yeah. Sorry. Yes, basically assembly for the web, right? That's the
Yeah.
idea. Um,
And what does that mean?
well, assembly is the native kind of the native language for machine, right? Well, most not it's not machine code, but it's the closest one. Most of your like assembly would be the closest to machine code, right? Um, like actually, by the way, the C compile to assembly before it go to compile to like object code before it go to machine code, or does it go directly?
So you can set like a flag to have it compile to like kind of assembly. Um, Machine code is like just zeros and ones, right?
Yeah, binary.
And then you have like disassemblers that can kind of convert it back to assembly, but um, there is sort of a one-to-one mapping, but it's yeah, it's not like the compilers compile directly to I think machine code.
Yeah, because
So
a
so
lot of
okay,
time
we
when
have this assembly stuff, and what is WebAssembly?
it basically so on the browser can now the browser since I think 2012 actually has been implementing this kind of standard to run kind of like assembly like code, right? So it's not entirely assembly; it's WebAssembly. So it's restricted to the browser sandbox. Still, you cannot do like kernel kind of assembly stuff, right? But you can certainly do a lot of stuff inside the browser in a very performant in almost native performant way, because it's all machine is the closest layer to the machine code. Well, it's assembly, right? So it's still not machine code, but it can be execute as fast as machine code. So you can
So
do a lot of heavy lifting with it.
what right? And what is kind of some of the use cases that we've seen with WebAssembly these days?
Well, video
Like
game,
any cool stuff made with
yeah,
it?
video game, you can definitely compile. So someone actually did that, right? So video game is one running a database, running Node.js inside your browser, right? So for example, Stack Blitz or Code Sandbox are the two kind of web app out there that's shipping a WebAssembly binary of all the dev tooling that you want to use, so that you can just run them all inside these WebAssembly boxes. VS Code, a lot of VS Code plugin allow you to ship. So if you want to target the web version of VS Code, and so the ESLint, right, the ES linter of VS Code on the web has to be, it has to be WebAssembly, or basically to make it support WebAssembly, or to make it support the web portal of VS Code for the web, right? They have to compile it to into WebAssembly, and so to consume it for the web kind of target for VS Code plugin. Yeah, so that's why it's
Uh,
pretty fast. And then we have what is it? Was it Supabase? Supabase was creating like kind of a wrapper, right? A wrapper around PostgreSQL, so that it's basically a WASM kind of wrapper around kind of a web. Sorry, not WASM, but yeah, it is. It was WebAssembly wrapper around what is it? PostgreSQL. So you can actually run a full blown PostgreSQL database inside your browser, right? And have all the terminal
that's
command and
amazing.
also managing it as if it's a native app, right? Yeah, I mean there are some restrictions in some of the capability of this of WebAssembly is still sandbox inside the Chrome browser, so you cannot really do stuff like you have to ask for permission when you want to do like file system, right? Like dealing with the actual file system, writing into the actual file system, and like actually do some other networking stuff. I think you still have to ask for like either permission or have to send message back to the front end for those kind of stuff like networking and file. But in terms of like just performance wise, right? That's why this is why it is used for like uh, the heavy lifting of all this kind of stuff, and also gaming too, right? So Unreal Engine, when they compile for Unreal Unity, for example, when they compile their game into web, like the web the web target, HTML5 target, right? Well, most of the time, they just compile down to WASM. Yeah.
Interesting. Yeah. So I guess a lot of the stuff that you talked about, the core theme there is just around like performance, right? If you want to use WASM, usually it's because you want something that's like very fast and very performant. And tying back to what you were saying in the beginning, that all stems from the fact that WASM sort of this feature in the past, you kind of had to do everything in JavaScript, and JavaScript had like sort of a more high level approach, and sort of it didn't really fit the need for a lot of performance stuff, so they created WASM to solve that issue, right?
Yeah.
So
Well,
what I'm
basically
curious about
JavaScript.
is,
I think that JavaScript run on JavaScript require runtime, right? JavaScript is not a compiled language, right?
mm-hmm.
WebAssembly, the WebAssembly is a compiled language. You have to compile down to that to run with, and then assuming that the interpreter of the browser is good enough, right? Which is just read the instruction and just moving by, right? That is pretty
Mm-hmm.
fast compared to having to interpreting entire JavaScript code and run.
Yeah. And what I'm curious about is like, okay, WASM, that sounds pretty cool, and maybe I want to build like a performant extension, one day.
Mm-hmm.
Um, how can someone use WASM right now? Like, what are the kind of sort of high level steps to start using WASM
Yeah.
in a
Is,
Chrome extension?
is it better to walk through the source code, or should I just do the high level first?
So this is I don't this isn't related to Plasma or anything. I'm just curious to hear like just if I was building a WASM extension, kind of what does the high level look like?
So the high level is assuming you're building was the WASM binary, right? So WASM running on the web has to be shipped as either there are two format, either use the WASM WASM format, which is a binary format, or you can use the WAT format, which is a text-based format, which is just basically for some kind of text formatting of the same binary for readability or for parsing purposes, right? Obviously, using binary file is actually much faster compared to using a text one because you have to reparse it. Well, the browser, okay, sometime I'm not sure, but I think the browser actually would do the parsing for you anyway. So the initial loading of the binary is usually not much of a problem. So you can pick which other format, right? So you pick a WASM target format, which is either the binary or the text format, and you have to compile your project for that, right? And you can use any languages, including JavaScript. You can even use JavaScript, but some of there will definitely be some API will be it will not be it will be a lossless translation, right? Definitely a super lossless translation down to WebAssembly because a lot of the typing on JavaScript will not. For example, right? JavaScript the type number is very broad, but down into WebAssembly you have to specify what type is this. What is this number type, right? You have to declare it. Was it like integer 32, float 64, whatever that is. So you do have to declare that. That's why. So there's a dialect for that, right? There's assembly script, which is a TypeScript dialect to write TypeScript like script that can compile safely down into assembly, WebAssembly. You can also use Rust, Zig, C++, and Go. A lot of language, even Python, also have binding. A lot of them have binding to get, to compile and get to target WebAssembly. Um, so so once you have the WebAssembly binary, the output of your program, right? Hopefully it's a very small and use. It should be small, but okay, it can be huge. It can be a Postgres kind of binary program, right? So it could be sizable. Okay, you have a binary, you have a WebAssembly binary. Now you have to add that into your web extension bundle, and you have to enable. So if you want to use this binary inside your extension page, you have to put WASM unsafe inline. I think WASM unsafe inline, something along that line to tell the extension that hey,
Where do you put this, and what is it?
it's a it is a content security policy. Content security policy is how you tell how an extension can tell the browser about, hey, this is the kind of the kind of resource that I would like to access. You're basically declaring upfront, this is the kind of stuff I would need to access to. Please let me access them, right? And there will be stuff that the browser will not let you, that the browser would not let extension do. For example, especially in MV3, for example, unsafe inline is not allowed. You cannot run arbitrary code from within the current bundle. Basically, you can do that inside a sandbox, kind of a sandbox process. Yeah. Yeah. So basically, there are certain restrictions with the CSP.
So you set up the CSP. You tell it, hey, I have a WASM thing, and
Precisely.
I want you to be able to like run it.
Yep.
Now what?
And then now inside your source code file, you simply create a WebAssembly kind of a runner. You pass down the path of the file, right? And that's it. That's pretty much it. You instantiate an instances of this WebAssembly runner, and you run any function you want that you have exported inside the WebAssembly kind of a binary.
Cool. Yeah. So okay, now that we know kind of what the overview of what it takes to set up a WASM project with an extension, I'm curious to hear kind of what are some of the difficulties that are presented. Like what are some tricky things that people need to understand?
Tricky. Can you? Well, so actually sharing data between the extension itself, extension code, and the WASM is quite tricky. You have to understand what data would this WASM accept, right? Because you essentially passing down data from a scripting environment, scripting runtime, which a number can be any number, right? Heck, a number in JavaScript can be compared to a string if you use only two equal. But when you pass it down to WebAssembly, you have to be very clearly tell it, hey, this is uint32, unsigned integer 32, right? So there's always that kind of problem when you're working with between two runtime actually, right? Especially if you have done if you have done game design before, to optimize certain thing, you would also want to upload it to the GPU, right? But then the GPU would only accept like certain kind of you have to use a share array, and the share array only accepts certain kind of data type, right? And you have to basically send data into the same share array buffer between the CPU and GPU. Okay, in some language it's a vector, right? You would share data through a vector, doesn't matter. But basically there's like a certain very restricted way for you to share data between these two runtime, so that the other one understands what you're trying to do, and then when it sends back some data, your current main running process also understanding what the output is from the WebAssembly. Yeah. So that's one of the tricky part. This actually happened even with just JavaScript runtime. When you're trying to work with a worker, for example, and you want to share data with the worker, you have to also send inside the worker certain kind of like for example, you want to share a kind of an array of item or an array of buffer. A lot of time this buffer doesn't translate well in the worker runtime, so you have to grab it inside a shared array buffer, and sometimes you have to massage it a little bit to make sure everything inside the buffer is aligned, and pass it over. Yeah. Well, otherwise, okay, there's another one easy way to fix that is just stringify. Just stringify and send as a string. You'll be done. You'll be fine. Yeah, but it take a long time, right? Sending buffer is much faster compared to sending string, but sending string is very easy. Yeah. So it's you either you can trading for performance, or you can trade for what is it? To solving the problem, right?
Like convenience.
Convenient, yeah, precisely. Yeah.
Got it. All right, cool. So I guess now that we kind of understand a lot more about WASM, maybe we can demo a little bit of our experiments with WASM, and in particular using Zig and targeting WASM to do some cool stuff with Chrome extensions.
Sure. Let me move on to the screen share one. Alright. So over here, I have the with WASM project. Let me just close some of this stuff.
And where can the people find this?
It's actually inside Plasmo tests. So we have a repository for everything experimental with Plasmo. Yeah, so RFC and bug reproduction. So every time that I work on a new feature for Plasma, I actually kind of play with it inside RFC, right? To get a feel of how it look like, and then shaping the feature inside the RFC itself, actually. Yeah. So the one that I was doing, the one for WebAssembly is inside EXP. It stands for experimentation. So inside EXP we have the with WASM zig, which point to another repo. Yeah, it points to another repository that contains the project itself.
Awesome.
All right. So inside this with WASM zip, we have pops up.txx file, and it basically. So I expose this. I use a hook. I create a hook to make it easy for me to consume WASM. Use WASM instance, and all it does is just it instantiate a WebAssembly package, which I just use fetch.location. I fetch the location of the package. I passing down the location using in the initializer. I fetch, and then I set instance. And so now, when I do like the WASM instance, I can call them. I can call add WASM instance dot add, which map directly.
What is add WASM here? What is this stuff?
So add WASM instance. Oh, add WASM instance is just the way I name it. It's just a WASM instances to do what a plus b.
But what is add WASM?
Oh, add WASM. That is a typing. It is a type. So I want to map the typing from my Zig source code to my TypeScript source code one-to-one.
So
right?
can we look at the Zig source code?
Yeah.
Just to understand like what's kind of like the functionality.
Yeah. So here's the Zig source code for my add function for my add module. I basically have the add function with a and b, and return a plus b, and have a test right after that, just expecting that 3 plus 7 is 10. That's pretty much it.
And what is Zig?
Zig is a language. Zig is a system language. It's a system language with syntax very scripty. It's a very scripty system language. It's a very scripty system language. It felt like basically it made me feel like writing JavaScript. It's very lightweight.
So here what we're doing is we're writing Zig, and usually when people think of Zig, they think of like this is gonna run like sort of natively, right?
Yep.
But instead, we're using this functionality of WASM to be able to put these functions and actually compile them down to WASM. Is that right?
So that's not the case, by the way. WASM doesn't really care too much about Zig or any other language. Doesn't matter, right? WASM is just so.
Yeah. No, what I'm saying is that like we're compiling these functions down to WASM. Precisely,
but it wasn't WASM that made this feature, right? It's actually Zig that designed their compiler so that it can compile down to WASM. It's a very I think it's a very conscious choice for them to do so. Comparing, for example, Rust. Rust needs a Rust binding. Rust would require WASM binding. Actually, they don't do a direct translation, direct compilation. And I think Go might actually be able to do compile down to WASM because Google.
Got it.
But yeah, certain languages might do some kind of binding instead of direct translation.
I think Rust uses LLVM under the hood, so I'm curious to hear kind of how they. I think I'm not sure how Zig does it, but yeah, that's interesting. Mm-hmm. Cool. So this stuff gets compiled onto WASM, and then we have an awesome kind of way to interface with it, right?
Yep. So So I have a hook here called use WASM instance, right? It take a type T, and then it creating the WebAssembly instances based on the location of the WASM bundle, right? So remember the first, so we have our Zig source code and we bundle that into the multiple, the WASM resources, right? So this code turn into this WASM file, and this is a binary file, right? And so in my pops up, I import those WASM file using the raw scheme. The raw scheme would basically take the location of these asset and put it inside my add WASM variable. And so the add WASM variable now contains the location pointing to my WASM binary. So I simply
So it's a file path.
It's a file path basically, and I put that into the location for the hook, and I also use the add WASM type, which is the type I declare here. And so add WASM simply describe the typing, the supposed typing coming from the add.zig. So this is manually, I have to manually type it, right? But in the future, it'll be very awesome if we can just read the zig code and we creating this kind of type binding for TypeScript. Yeah. Yeah, and it definitely it is definitely possible. It just we haven't got time to get to that yet. But basically, because Zig use I think the one thing about Zig is that Zig compiles down to an AST, right? So you can use the AST abstraction to translate it to another AST, because AST is just a representation, right? It's a higher level of representation of the language, of the code itself. So you can certainly translating Zig AST to TypeScript type AST. I think last time when we talked about this, you did ask me about why can't we just translate TypeScript directly to Zig, right? And yeah, the key problem is typing. The typing of TypeScript is not as strict as Zig, right? Zig requires very strict kind of numeric type, like uint 32, float 64, stuff like that. There's the type number doesn't make sense, but it makes sense in TypeScript, so it will be a lossless translation.
Yeah, I can imagine you can create all those types in TypeScript, right, and then just enforce them to use
basically, and that will be assembly script. That will precisely become assembly script then. Yeah.
Got it.
And you would go directly from assembly script down to WebAssembly. You don't have to worry about Zig. Yeah.
Cool. So if you go back to like pop-up, so what we're doing here is we're basically using the hook to register sort of the WASM instance, and then how do we actually use it?
So the add WASM instance now dawning the add WASM interface, right? The add WASM is kind of interface of saying, hey, what this WASM have inside of it, right? And so it has an add function that accepts A and B and return a number, and that's precisely what this thing have. So I have to check if it's ready. So when the WASM is ready, will be true. This instant will turn into truthful, and when it's truthful, I can do add WASM dot add, and I'm passing down two number A and B, and that's pretty much it. And I can use it inside this rendering too. Yeah.
So what you're saying is that the sort of string representation of the function will still exist on the compiled version of the WASM instance. So even if you didn't have typing here, the .add would still register as a function from Zig.
So the .add is kind of a characteristic of WebAssembly, right? Of how WebAssembly take the export. So on Zig, we actually do export function add. This export keyword tells the Zig compiler that, hey, when you compile out your WebAssembly, make sure to export this function out into the outside namespace. And that's precisely what happened here. And yes, it work without this typing. The typing is just for me to have fun with it, right? The typing is just like just to make it have a dev tooling experience. Yeah, it complained here because hey, I don't know what the hell WASM is. I don't know what this thing is. It's unknown to me.
Yeah, the thing I was curious about is like just understanding, um, it's like this will work, right?
Mm-hmm.
Got it. Yeah, I was just curious to hear like kind of so like the string representations of things because it's human readable stuff, right? It's not like machines don't care about like ADD, right?
Are you
They
talking
just care
about
about some.
so? Are you talking about the A and B? Or are you talking about the WASM instance?
What I'm talking about is like in the add.zig we have a function and we compile it down to assembly.
Yeah.
Yet this still understands that that function's called add. So there
Oh, yeah,
seems to
yeah.
be like they're preserving the names of the functions, which
Yes,
is
I
useful.
think yeah,
We don't
precisely.
have to do it manually.
Yeah, I think this is that. I think it has to came from the zip compiler. I'm pretty sure with Rust compiler, there was actually different namespacing. They would actually add namespacing or some kind of binding too, where the name is totally different for sure. There are cases like that. Yeah, where the
I
binding
see.
is there are cases where the binding is definitely not one to one at all. So it really depends on how this compiler treat the exportation of the user intention, right? Yeah.
Awesome, cool. So maybe we can head over to our kind of last section, which can be like a discussion.
Yeah.
Awesome. So I have a couple of questions here. Like, other than performance, how do you think WASM sort of can be used to improve Chrome extensions?
Hmm. Well, um, we could talk even bigger than just extension, like the entire ecosystem, right? The entire software ecosystem, not just extension, web app, native app, etc. The ability to use WASM allow you to now compile any other software in the world, right? Any kind of software in any other languages, assuming there's a compiler that can the compiler from their languages into WebAssembly. You can now use the exact same software on the browser, right? I think that's a key power there. So in terms of extension, you can now implementing almost any feature you see in any normal app, in any app at all. Yeah, you're now not limited by the runtime constraint of JavaScript. JavaScript is very powerful, but it has a constraint that is single threaded and it's very yeah. The performance is the key limitation of JavaScript, right? Imagine if JavaScript is just as fast as C, we would not need this. But once it becomes as fast as C, you start thinking about. I think it will lose certain dynamic, right? Because the cool thing about JavaScript is that it's a scripting language, script and a very lenient scripting language at that. By lenient, it doesn't care about the type, right? You can passing, you can literally do a split string, right? You can split a string with negative indexes, still good. It do all the checking for you. The runtime itself do a lot of error checking for you, so you don't go into segmentation faults and stuff like that. Yeah.
Right.
So I think it's the same case where people decide to trading performance for convenient, right?
And okay, so WASM, we know that like yeah, performance is like really good for performance. Also, what you're saying is like you have any application compiled in any language, if that language also has some sort of way to compile down to WASM, now you can use it, and that's super cool. So given all of these like interesting stuff around WASM and also kind of the difficulties we talked about before, we're like, what do you think about in terms of the future of WASM, and do you think that WASM will be widely adopted by the greater Chrome extension community?
I think people would, yeah. I mean, people are starting to use it, right? I mean, a lot of the startup that building like a very complex tool for the web have to use WASM, right? Because JavaScript not good enough, and you don't want to wait for your. You also don't want to. The thing is, JavaScript runtime suck. It's very bad performance wise, but the machine is running on is very good. The machine that you know, the machine that run the browser and people's machine getting better every year, right? Double the
But
power.
what kind of Chrome extension would require something like WASM?
The kind of okay, I would not talk about a single extension, but imagine a suite of extension, right? A suite of extension that eventually forming a browser, a customized browser.
So this seems like a very niche. It doesn't seem like a lot of extensions would kind of benefit from this. Most extensions aren't building a browser, right?
In my opinion, most extension not, but extension become big. Will have to though. For example, Microsoft has a suite of Office product, right? But they launch Word. They're launching Word first. Word is the first product, and then they launch Excel and then PowerPoint. But all of them are under the same suite of product, right? To do certain thing, and they are each of these software are just extending the operating system, right, to do certain part of the Office documentation process, right? So previously, people working with paper, and so Microsoft has to build extension for the on top of the paper, right? For the paper, for the typewriter. Nowadays, people work with the web actually, right? So instead of writing on paper, people writing on on the web, people writing on web platform, right? Then people will start having to build a suite of a suite of software to help people working with this kind of this with the web actually, with the web as a paper, right?
So why haven't we seen this in the last like 10 years since Chrome extension's been around?
Well, I think because Chrome extension at the moment, especially the ecosystem, is quite hostile at allowing extension to go beyond like just being a small extension. I think the so first is like the platform itself, Chrome extension platform itself. I think there's a sense of they want to keep extensions small so that either the feature get absorbed into Chrome itself, into the browser itself, right, or it just stays small. And secondly, um,
That doesn't like if that were the case, why are they enabling WASM and doing all this other stuff?
because WASM is
Around
on the web. WASM is an initiative for the web actually. I think for the larger
So,
web.
but if the browser didn't want to kind of have extensions be alive, they would have simply just not allowed that CSV directive that we talked about, right?
I think it would make creating extension not even. It will not make extension even any more kind of a even another browser because there's no security. There's no security problem with it. You know, there's no security problem with WebAssembly. If
Right,
the,
but if they don't want kind of, I mean, there is, right, like WASM can't be viewed as source code like JavaScript can, so it reviews harder, so it makes the lives difficult, and you can imagine that the browser could say something like, this makes our review too tough, we don't want to support it. I think it's a very reasonable thing to have.
yeah, but then another browser come in that support WASM and supporting much better, much faster extension. I believe.
Sure, so like MV3, right, like Firefox said that they want to support these different things, but like Chrome is still going ahead with MV3, so that hasn't historically been the
No,
case,
because
right?
I think MV3 is a different story comparing to WebAssembly, right? MV3 is kind of MV3. There's a lot of like security consideration in there, right? There's good intention in there. When MV3, it's not just okay. Sure, there's a lot of it that can be interpreted as a way for the app monopoly to retain its power, right? So there's a lot of that, but a lot of MV3 is also improving on adopting some of the new work has been done, right? For service worker model, service worker module, and all of this new like CSP kind of like security consideration that they have seen so far with web extension, right?
Right, but in terms of like developers though, like this doesn't really help developers. Like sure, it can help the end users. So the kind of point I'm saying, right, is like,
which is the platform doesn't care, right? I think at the moment the platform does not care, and developer.
but like even if other browsers do care, the platform can still do whatever it wants. That's kind of my point, right? So like, so to your point, like if another browser said, "Oh, we support WASM," like yeah, sure, developers might be interested in that, but I don't think the end user really cares, considering the historical like precedent, right?
I think that when the application become, or when the extension of the application, right, or when anything on top of the application become really good, people were flocking into it. For
But I don't
example,
really see any examples
so
of
Slack
like,
and
I mean,
Discord, for example.
WASM has been around for a while, but the Chrome extension, there's no like Chrome extensions built using WASM that I would kind of even point to.
I think it's definitely because the need for the need for huge performance is like because the step needed to create a WASM bundle and then to architect all of that to run well. Well, it's quite easy because we have a very simple setup. But if you were thinking historically, when you have to set up all of this binding, all of this bundle, the effort of optimizing take much more time than just getting the product done. And if the product is very useful, is willing to have people is willing to suffer through the performance, even get the job done.
Right. So WASM's been around since 2012, and I can imagine that um, it's been available on Chrome extensions for a while. Like, what are some like big WASM extensions out there?
I don't think there's any at all.
So there actually is there's some crypto wallets that use WASM. So you can imagine with crypto, like
Do they run
a
it
lot of
inside?
times.
Do they run it inside the wallet, or do they offload it to the chain?
So all of their crypto stuff is actually run client side, so they use WASM for that.
I see.
So they compile their Rust down to WASM, and then they use a Chrome extension. It's really cool.
Which one? Which
So
one is?
they haven't released yet,
Oh, okay.
or maybe they have. I have not been looking, but they've been building it out. So shout out to those guys. But yeah, so
Well, but they are not released.
that's
So
super
basically, they
interesting.
haven't released it yet. I think that like back to the question, right? WebAssembly, web extension has been around for 10 years. How come nobody give a shit about tooling? How come it's so bad? Right?
How come it's so bad about what?
How come like like how come nobody built more stuff like this?
Like this? What do you mean?
Well, WebAssembly, right? The question was, it's been around for a while, but nobody really built, like more WebAssembly, or nobody cared too much about the native performance, or better performance of extension,
Yeah.
right? The original question, I think it's just because it's too hard. The setup's too hard and it's too difficult.
So if that's the case, like, wouldn't it be the case that someone should have built this a while ago? Like, why haven't they?
I think that
People have
nobody.
encountered this problem in the past, right? So like, why isn't there anything to solve it?
No, it's very hard.
If
It's
it's
a
that
very.
hard.
I think it's a very hard problem, and nobody cares to think too deeply about it. Care to actually abstract away the entire way. It take so for example, web development has been around right for almost 30 years, and Next.js came up 10 years ago. Next.js came up after all the HTML and all of that stuff, right? Almost 20 years, after it was all announced, right? So Next.js, so take Next.js as an example of how a platform has been mature for quite a long time, right? So 10, 20 years. But then it took it, it took seasoned developer, people who understand the pain point of the problem, who have worked on extension infrastructure, right? And also understanding that what can be done in the space, right? It cannot be so throughout 10 years of extension, right? The first 10 years, like the first 10 years of people start testing out how to build extension. Actually, I don't think anyone actually think too much about how can we automate all of this away and just make it easy to make extension. Actually, I think people just care about the application. People haven't cared about the tooling yet, and if that's the case.
So my question to you then is like, I think like there have definitely been sort of kind of people working on sort of this, like building websites using this sort of ideas that Next.js provides. Is just that maybe they didn't have a cohesive framework and so on. But I'm not really seeing any like WASM projects out there for extensions. So that's kind of the thing that I'm curious about is um, Like what makes you think WASM will kind of be more widely adopted by the extension community?
Um, so for example, they can do things that was impossible before. Impossible actually.
So it's can versus need, right? Like I can like add numbers now like much faster, but like
You can now
why do I
decode.
need that?
You can now transcribe an entire video using the web, right? You can transcribe any video that you're watching right now without having to go to a
Again,
separate website. Without having to go to a
again,
separate website.
sorry, I didn't hear what you're saying.
Oh,
What can I do with the video?
you can transcoding the video, encode it, download it. You can do it. You can add like real-time filter right to the video, or you can do a lot of like very intensive stuff uh, with like with any asset on the web that previously would just lap your entire browser out, right? And it's the same with, for example, right? When you open an image on your desktop, for example, right? Um, is it usually the experience is much better if you can do everything inside the same app, right? Instead of having to dragging from one app to another, right? Like, hey, I need to crop, so I need to drag it into the cropping app. I need to, paint the colors, so I drag it into another app, right? So that is web. Those are website right now. Website right now are just that. They're a separate app, right? Where you drag and drop file from different app to get something done, right? Extension work on top of the website, so now you work directly with the asset of the file, right? With the asset you're looking at. So it could be a video, it could be image, could be. So now you have this abstract layer. You can imagine in the future, right? With WebAssembly, we will start having a file system, an actual file system running on top that is as performance as the actual file system on the real host.
So wouldn't this be something that like browsers can give us?
Why
do we need to implement it ourselves?
Yeah,
like
they might.
Sort of like
they might as well. I think.
From WASM.
Yeah, I think they might as well. This is the idea, right? The idea is that because the thing is the browser is also moving very slow. It's a platform. The platform generally move very slow. That's why they have to offloading the capability of personalization or making thing for specific use cases to extension, right? That's why extension, because the browser itself also need to be quite I can imagine they have to be conservative at what they can add over time. And I think they do the same thing, right? Precisely what Chrome is doing is what I just describing. Only Chrome can do it because they are owning the platform right now, and they can shut down any extension they want by incorporate inside.
So I think it's also the opposite, right? Like for example, there is this live streamer that I watch called Ludwig, and he actually has his own Chrome extension. I think it's pretty cool because he adds features on top of YouTube for live streaming that don't exist currently for all his viewers. So he asks his viewers, hey, install my Chrome extension, and now you can have all these awesome features on YouTube that you otherwise wouldn't have. He built it because he transferred from Twitch. Twitch had all these awesome features, but YouTube was just lagging behind. So he hired a couple devs, built out a Chrome extension. Now YouTube has those features. And so like in that way, Chrome extensions, see, the thing is like Chrome or like any of these browsers, I don't think that they really care about YouTube and things like that. So I think in that way, it's sort of like YouTube is kind of benefiting because now all of these different YouTubers can actually tell their audience, hey, use our Chrome extension, and then now they have all of the cool features that YouTube has been building for years, and it's sort of like it takes a while to build these things, and sometimes your users, kind of your viewers, might want some features like emoticons that maybe the general population doesn't really want them on YouTube, and YouTube doesn't want to build that product out. So having this sort of customer segmentation in this way is very fascinating. So in the same way, like building features that kind of enhance Chrome, maybe having this file system or grouping tabs in a certain way, and adding features onto bookmarks, that also enhances Chrome. And I guess all of these platforms can look at these extensions in two ways. Either, well, three, I guess. First is like, that's awesome. We're so glad. Like, most of our customers don't want these features, don't want these features. So at the end of the day, we're not going to build them out. So they're very friendly, receptive. Like, yeah, you do you. You enhance the experience of this segment of the customers that we don't really have time or we don't really care about. The other one is they're very negative. It's kind of what you're talking about. They look at this and they're like, dang, this is a really nice feature, and they steal it and they build it as their own. So maybe YouTube takes some of these features and applies that, or maybe they've been building these features out and it's just now they see product validation. And then the kind of third case is they're sort of neutral and they don't even know they exist. So yeah, it's super fascinating, the like dynamics, because at the end of the day, right, like this person extending the software isn't the software maker. So you have to think about sort of how that relationship works. It's very fascinating stuff.
Yeah, I think it's
Cool. All right. Well, I think we sort of talked a lot about WASM, and I think
yeah.
I think we covered a lot of stuff. Anything else you would like to share?
Shout out to sponsor. We got a sponsor on GitHub.
Yeah, we did. Let's talk a little bit about that.
Yeah. I'm gonna pull up the screen share on the screen share.
Yeah, it's NFT Gamer TV, right?
Yeah.
Yeah, so shout out to NFT Gamer TV for sponsoring, and also for Sam. Sam does NFTs for boosting our server. I think TD from NFT Gamer TV also boosted a server, so now we're at a level 2 server on Discord, which is pretty awesome.
Yeah.
And
What the
thanks a
perk
lot
of that?
for this.
What are the perk of that? I'm not sure. But yeah.
Yeah, we should definitely take advantage of all the perks. So we should research that, and yeah, it's super awesome. Really happy, and thank you so much for the sponsor for helping support open source.
Yeah. All right.
Cool.
What else? Anything else?
All right. Well, nothing on my end, and if that's it, then let's say goodbye, and let's see you guys next week. If you have any thoughts on like potential topics to discuss, we have a bunch of topics that we definitely want to discuss, but also want to hear kind of from the community to see what you guys are interested in, and maybe if you want us to explore a certain like direction, let us know. We'll keep doing this. If you prefer the old format of demos, also let us know, but that's basically it.
All right then. Take care.